Hi, we're the GearChangers, and we're going to be giving our technical presentation today. I'm Alan, this is Solar, Milan, and Emmett. So we're going to start off this presentation by talking about our spaceship pulley contraption behind me.
The first part of our performance includes the spaceship landing on the Martian surface. The pulley system allows us to traverse the spaceship across the hypotenuse of our frame, and it uses a clothesline pulley and some fishing line.
First, I'm going to trigger the IR sensor to begin the landing process. You're probably wondering why we use the fishing line. We used it in order to make the spaceship look like it's actually flying. Other electronics in this include the 12-volt DC motor, an L298 motor driver, and an Arduino Nano that powers everything. As you can see, when the IR detects it for the second time, the spaceship comes to a stop and the motor comes to a stop via feedback loop.
So now let's talk about the structure of our rover. So we chose to use wood as it offered the most flexibility in size, shape, and customizability.
And in regards to the electronics, we have 4 RGB LED strips to indicate the life of the rover. We have 7 IR proximity sensors for human-robot interaction. We have an ultrasonic sensor in the middle, and if you want to come closer, we have a head here, which is actually a hologram powered by a Raspberry Pi. And this hologram, as you can see, indicates the % charge of the rover. So what I'm now going to do is I'm going to start fixing the rover like I would in a performance. And what you're going to notice is that this volcano here, which is our main robot, is going to rise up and transform into an alien. So here we go, I'm going to start fixing, and there we go. And now we have an alien. So what I'm now going to do is continue fixing the rover like I would in my performance. So here we go, I'm fixing, and okay, look at that, we got 20% charge, so I am doing something. And fixing, and unfortunately I'm still stuck at a 20% charge, so I mean, what exactly do I do?
So this is where the alien robot comes into. Our robot includes a scissor lift made of VEX C-channel and uses tracks and dollies, which are parts commonly found in a 3D printer, to make sure that our scissor lift can run as smoothly as possible. We have this motor that drives this threaded rod, which is connected to the dollies to rise the entire contraption. This plank is connected to a tank drivetrain to make sure that our robot can move freely. So the top half of our robot consists of a metal cage made of L-channel. It includes some of our electronics, as well as our hands and the head.
During our initial design process, one of our largest issues was driving the scissor lift. In our original design, we had a wooden cross member and a regular threaded rod. However, after going through 3 of these wooden cross members, we realized that this compromised its structural integrity. Instead, we used an aluminum cross member along with steel reinforcements on the dollies and a more effective threaded rod.
So for the electronics of our drivetrain, we use 4 Rev Robotics hex core motors to drive the drivetrain. And for the pulley system, we use a 24-volt motor attached to a threaded rod, which moves this cross member attached to our dollies to allow our scissor lift to move up and down. We also have a Bluetooth module that allows us to communicate with our rover, who also has a Bluetooth module. And we have a Raspberry Pi attached to a Pi cam for our crystal detection algorithm. So now I'm going to show you guys a demonstration of handshaking the top half of our rover.
So I'm just going to give our alien here a handshake. So he's going to present his hand, and we're not giving it a handshake. Now after this, it's going to rotate and tell me the crystal I need to fix the rover. So it's going to rotate. So now as it's rotating, what the Raspberry Pi is doing is using the RGB values in predefined sections in order to send the signal to the Arduino. So what you just heard was that the green crystal was in front of our alien, which means that that's the one we need to fix our rover. However, what I'm now going to do is move it around. And after I move it around, you're going to see the alien rotate. So I'm just going to move it here. And as you can see, it lined up perfectly with the green crystal, which is exactly what our algorithm is doing. And we get some auditory feedback. So now I'm going to take this green crystal, hand it over to Solar.
So I'm going to take this green crystal and put it on top of the ultrasonic sensor as acting as putting the power source on top of our rover. And as you can see, we get these green LED strips light up, indicating a successful power up. Now, if you look at the hologram, after a few flashes, you'll see this 50% go to 75% and all the way to 100%, indicating that we're all good.
Finally, we'd like to talk about how COVID-19 affected our performance. Our in-person meet time was severely limited, giving us about only a 1.5-month timeline to work with. We also participated in various hackathons to help sharpen our programming skills. Finally, we used Zoom in order to plan and reconvene as a team.
This concludes our technical demonstration. Thank you for listening, and we hope to see you live sometime soon.